Okay, I have a new tablet, so we'll see how this goes. This is section 5.1, and we're just introducing the natural logarithm. So there we go. Now, I say we're introducing it, but it's a prerequisite in the sense that we expect you've had pre-calculus courses that include logarithms, including the natural logarithm. But remember that so the way the text starts, and I think it's a nice way to start this, is that we've got that power rule. So remember the power rule. And if I want the antiderivative of x to the n dx, I just add 1 to that exponent. Whoops, I'm not sure what just happened. X to the n plus 1 over n plus... Oh, I've got a little button on my stylus that makes it into an eraser. Who knew? Okay, so so that's our power rule for antiderivatives. And of course, this works as long as n is not equal to -1, right? Because if n is equal to -1, this rule would produce x to the 0 over 0, which is definitely undefined. It's not indeterminate, it is undefined because, well, I suppose unless x happens to be 0, but so if n equals -1, that would imply that we would get x to the 0 over 0, but that's 1 as long as x is not 0 over 0, which is definitely undefined. That's not indeterminate at all. That's just plain undefined. And so, if n is -1, we don't have an answer to this thing. And so, one might ask, well, what is, if I said, what is the antiderivative 1 over x dx? Good question. Now, we can graph 1 over x dx. Oops. There, but hey, we'll get it back. There we go. That was easy enough. I probably hit something somewhere. So the antiderivative 1 over x dx, we want to get that. And if I look at the graph, at least for positive x, right, we have something like that. That's 1 over x, and so certainly it seems like there ought to be something like an antiderivative in the sense of area under the curve and definite integrals. If I pick an area like that, that exists. So the definite integral exists. So if I said an integral from a to b of 1 over x dx, that would exist. Okay, that exists. Well, certainly if 0 is less than a, and we'll go with less than b like that. We'll just say that, we don't have the limits of the integration go in the opposite direction. So all this exists. So what we do is we define a function using the second fundamental theorem of calculus, and we say, okay, we're going to define the function natural log of x to be equal to the antiderivative from 1 to x of 1 over t dt, oops, dt, I did a dx there, dt, and we'll insist that x be greater than 0. So that means we could go from like 1 to a half, and that just means we would get the negative of whatever we got from 1/2 to 1. Okay, so we define it that way, and then if we define it that way, well, again, by the second fundamental theorem of calculus, the derivative then of the natural log of x dx is equal to 1 over x, right? It's right there. And so there we have this function. So that is the definition here of the natural log function, which is very different, really, than what you got in pre-calculus courses, because typically in pre-calculus courses, you first learn the function e to the x, the exponential function e to the x, and then you said, well, what's its inverse function? And we said, well, that's the natural log of x. Well, here, see, in this course so far, we haven't introduced the function e to the x, right? We have simply stayed away from that type of function, an exponential function in general, even 2 to the x, that kind of thing. And so here we first start defining things in terms of logarithms, not exponentials. So, it's very different that way. And the reason most calculus classes do it, or, well, many calculus classes do it this way, is because, doing it as an integral here, that's a really nice definition when you start thinking about it, right? Because I get this function 1 over t or 1 over x, I get that function, and now I get the idea of the second fundamental theorem of calculus, and defining a function this way by making this upper limit a parameter. Well, actually, sorry, not a parameter, a variable, and in using the function here this way. Now, just because I define it this way doesn't make it any easier to just know what that function is, but nonetheless, I can define it this way, and if I have numerical stuff, I can get that function that way. So what we'll do is we'll stop this video here, and then we'll look at this integral on Desmos.